another chapter in Form 5, Chapter 3, Integration. Form 3 of integration is the core or the essence in Form 5 syllabus. It covers a huge number of questions in SPM, and it will require the knowledge of differentiation from Form 4. You may watch my Form 4 video for differentiation. But the concern for this video is for Chapter 3, Integration. Before we start with the law that involve, I'm going to show you on how to integrate. First of all, you need to define certain term. This sign is called integration. Whenever you have integration, you have this sign. This is a infinite integral, meaning there's no limit from where to where. So whenever you integrate a function, your result should have a constant c. A constant. This is a constant number. Just a number, a c. Now, the term being integrated is called integrand, where the result of the integration is called integral. Integral is a result. The function being integrated is called integrand. Now, they are interchangeable. Now, say for example, if you were to differentiate a function, the same function over here, the result will be 2x. Now, if you were to integrate it, you will get the same answer. You will get back the original function. Think about this because there are some fundamental questions in paper 1 that focus on this definition. Now, first law, there are a total of 5. There are some rules or law for differentiation. First one would be the integration of a constant, maybe a number, k maybe. I don't want to confuse with the c here, so I use a k as a constant, just a number. Differentiate a number over dx. Your answer would be quite straightforward because integration is all about adding of an x in terms of the power or the index. Integration is all about adding an x. So here there's no x here, x0, so our result will be k, get an x. It's a 1 here, but doesn't need to write it. And you have a constant. Give you an example. Integrate of a number, say 6 dx. Now you should expect answer should be 6x plus a constant, c. Integrate our constant. Any number will do. Simple, straightforward. 2. Second law. Integrate of x to the power of n of any number more than 1 dx. For this one, integration is about adding of an x, so there are some rules you need to know. That will be x, n plus 1 plus an x over the number, the index number. We have learned about index in Form 4. And don't forget about a constant, c. Now say for example, integrate x to the power 4 dx. Then you should expect answer should be x. 4 plus 1 is 5 over the index number 5 plus c. Well, understand that it will take some time for you to adjust yourself. Plus 1 is 5 over the index number. Compared to differentiation is that you bring down the number. So this is integration. Third law. Now with a constant and an x. Integration, maybe a constant, any number, maybe k. No, k is no, I don't want to use k. It's just a number, it doesn't really matter. Don't want to confuse with the first law. Says maybe a x n dx. Now for this, the integration is x, meaning I want to add only x. Those that's not related to x, you bring it out. You might confuse the third one with the first one, but actually they are the same. If it's a constant, you bring it out, the constant. So here, you may rewrite it as a xn dx. And therefore, that would be a x n plus 1 over n plus 1. That will be plus c. This is a combination of 1 and 2. Like, for example, in the first case, you bring out the k, that will be k integrate of dx. Maybe I use a side note of another color. Well, this one here would be integration k dx, and therefore that will be kx plus c, and they are of equivalent. I'm going to show you here. Just like for the others question, example says to integrate 4 x cubed dx. X cubed, so 4 bring out, factorize it, 4 x 4 over 4 plus c. 3 plus 1 is 4. So therefore 4 and 4, therefore it goes to x4 plus c will be the answer. Now I'll give you some time to have a look at it. You may of course pause this video, or you may download it first, you pause it later, and view it at when you are free and when, or perhaps you are doing some exercise, and you should try on some basic exercise from any revision book or any books available before you proceed to the next section, next law. You'll be on next page. That would be our fourth example. Not example, in the fourth law. I will define a fourth law. Now, that will be the integration of two different functions for integrand. Says I have one function fx plus gx in terms of dx. Now, this is rather straightforward, because if you have two functions, what you do is you integrate one by one at a time. So what you do is fx dx plus integration of gx dx. Plus or minus, doesn't really matter, you just follow exactly. Let me give you an example, because that might seem a little bit too complicated of a function. You shouldn't be complicated at now, because you have learned it from chapter 1. Integrate two functions. Maybe I have 5x cubed as my first function. Maybe I have subtract 3x as my second function, and differentiate in terms of dx. So therefore that would be integrate 1 at a time dx minus integrate 3x dx. Wow, straight away this is what I have shown you earlier. You should get the answer. So that will be 5x, 3 plus 1 is 4 over 4, subtract, that will be subtract 3x squared over 2, remember about plus c, because you have a c here and a c here, then what I'm going to do is you summarize it at once. There's only one c, you do, you get the answer. You may simplify it if you could, otherwise this should be your final answer. Last one, the fifth law. There are only 5 laws, and you might need to take some time to get used to what you have gone through. Go back to your exercise book or any practice exercise to practice on the simple concept. You take some time to excel into it. The fifth one is called substitution. Substitution method, could be hard initially, but once you get along with it, then you find that it's very easy. In the form of a AB form. Whenever you have you come across with a function that have ax plus b power n. When you come across with this form of integrand, then there is a special care need to be taken. Says you have a question that will ask you integrate or ax plus b n dx. Theoretically, if you could take it in this term as one form, like in example 2 or law number 2, what you do, you can straight away write the answer as in ax plus b n plus 1. That's what we learned earlier. But here, over, you differentiate whatever is at the x, meaning you differentiate ax, you will get a, and n plus 1 is the original number that you bring it down, remember we have plus c. It helps you a lot if you take this formula in and remain. A is from here, the differentiate of ax, just like how we had one example or one law in integration, or one law in differentiation in form 4. Here you differentiate ax, bring it down here. Right? Another approach, or the substitution method. Integrate ax plus b dx. Now, here you substitute whole term as u is equal to integration of capital U and dx. So therefore, you will need to let u is equal to ax plus b. Now if ax plus b, what you do next is rather complicated, not complicated. What you do, one side is u you need to find out how u and x are related. In order to do that, you differentiate u du over dx, so that you can have u and x. Du dx for this function, that will be a. And then you'll be able to find out what is dx. You substitute into this equation. Dx would therefore be, bring it up, du over a. Bring it up, bring it down. This is what you get. So then you substitute into the equation here. Eventually, therefore, integration of u, and my dx is now du over a. A is a constant, so you may factorize it. That would be 1 over a. This is a normal integration now, un du. So this is, you add u into this equation. Therefore, that would be 1 over a. Here would be u n plus 1 over n plus 1 times and your plus c. You substitute what is u to here, you get the original. Therefore, that would be 1 over a times, my u is ax plus b power n plus 1 over n plus 1 and plus c will be the answer. You get exactly the same answer as here, so that it will be easier if you just take it in n plus 1, differentiate whatever inside. Two methods here. You may want to copy it down, copy it out, and then you practice on some exercise. Next, I'll give you an example. The next page. Example that would be say integration of 3x plus 8 power 4 dx. So therefore, straight away I can make use of the equation. That will be 3x plus 8, 4 plus 1, 5 over 5, but here is 3 times the index number 5 plus c. Therefore, the answer would be, you may work on the substitution method. You should get the same answer. You may do it at your side, your end. You may pause this video, work on the substitution method, rewind to the previous second, and eventually you should get the answer. Now, question like, say for example, would be straightforward. Say for example, they ask for form an equation from a gradient function. You'll be given more example. Example 1. You're given a gradient function. Gradient is always defined by dy dx. Gradient function is equal to, say, is what? Maybe mx plus 9, where m is a constant, and turning point You might be surprised to hear or to see question like this, turning point in integration, but it's completely normal. They let you know of the turning point so that you'll be able to look for the constant c once you have in the integration, so that you will able to substitute into the equation, you get the c. Turning point 3, 2. Then find what is m. What is m? So for this kind of question, it will be quite normal in paper 2, or maybe it will come out in paper 2 if you join with others chapter in paper 2. So to start off with, in order to get m, what can you do? You make use of the term given turning point. By mean turning point, meaning dy dx is equal to 0 when it's a turning point. If you still remember, or Form 4, we have turning point. That's the point up to there, where dy dx is equal to 0, where the gradient is 0. So, if you know this, based on the question given, turning point, therefore, mx minus 9 will be equal to 0. And therefore, your x will be equal to turning point. Oh no, it's not x. Sorry. When x is equal to 3. So therefore, 3m minus 9 is equal to 0. Therefore, my m will be equal to 3. Bring it over. 9 by 3 is 3. And then find out the equation of this curve. What's this equation? So in order to find equation, maybe I do it here. Equation. The curve. So in order to find equation of the curve, what you do is your equation y will therefore be equals to integration of the curve. This m is 3, so it's 3x minus 9. This here, dx. Go back to our first page just earlier of the video. If you were to integrate the differentiate, you should get the original equation. So that's why I'm doing it. What I'm doing now is to integrate the integrand, where this is here. I will get the original. Now how you do that? Now if you were to bring this up to here, you get your y. You integrate it, then you get the y equation. So here, two different functions. Your y will therefore be 3x squared over 2 minus 9x plus c. How do you get this c? Because you need the equation. You can't just left it here. You don't get full mark in your exam. To get c constant, you make use of the turning point. You substitute when x is 3, y is 2. So therefore, this is 2. This is put in your calculator. This is 3 over 2. That will be negative 27 over 2 plus c. You need to put in your calculator, calculate this accordingly, and therefore your c would be equals to 31 by 2. And therefore, now you get the equation y is equals to 3 over 2 x squared minus 9x plus 31 over 2 as the final answer. So this will be the equation that they'll be asking for. Well, this wraps up the first part for integration. The following section, next part, that would be looking for the value and also the area under the curve, or area under the curve, and the volume of the curve when it's rotating around certain axis, maybe x-axis or y-axis, the region bounded by a curve, or x and y-axis. That would be the second part of it. Do some practice exercise are required for this 5 law before you proceed to the second part for integration, area and integration, area and volume, sorry. Good luck in doing those questions. Subscribe to my video YouTube channel, from our YouTube channel, or perhaps you may share my video with friends if it's good. And don't remember to like my video. They are free of charge. Why not sharing it?